Good evening. Autumn is now upon us, and the nights are lengthening by about 30 minutes each month as we head into Messier marathon season. That is the time of year when amateur astronomers try to see all of Charles Messier's deep sky objects during the course of one fascinating night. I would like to thank award-winning photographers Zlatko Orbanik from Paula, Croatia, Terry Hancock from Fairmont, Michigan in the United States, and Oliver Sesenitz from Leibnitz in Austria for allowing me to use some of their splendid images in this month's programme. Zlatko Orbanik and Terry Hancock have both just completed a detailed study of Messier 33. This image of the galaxy is a joint project with contributions from 9 amateur astronomers. The image processing is by Joseph Denitano. Terry Hancock took this image of M33. It is a collection of amateur data, all captured from his observatory, with 5 cm and 3.6 cm refractors, along with a Takahashi 7.2 cm astrograph. As you can see, Terry has identified some of the nebulae within the galaxy. I will have more to say about M33 later in the programme. Let us begin by looking into the northern sky, where one of the strangest galaxies is now on view. Known as the Cigar Galaxy, Messier 82 lies in the constellation of Ursa Major, the Great Bear. It has been given this name due to its appearance in astronomical photographs. Look low down in the northern sky and you will see the familiar pattern of stars known as the Plough, with the handle on the left. From left to right, the main stars are named Alciad, Mizar, Alioth and Megrez, with Phakedah, Merak and Nubai in the bowl. The Plough is part of the constellation Ursa Major, the Great Bear, with the handle of the Plough forming the bear's tail. The star Mizar, shining at magnitude +2, is a fine double star with its magnitude 4 companion Alcor. The pair is known as the Horse and Rider, and these stars are themselves spectroscopic binaries making up a 6-star system. However, only the 2 principal stars can be seen, which is a test for keen eyesight. There is also a third magnitude 7.5 star in the field of binoculars, known by the odd name of Sidereus Ludwiganium. This was named by an eccentric German astronomer in 1723, who thought he had discovered a new planet and named it after a German prince. The constellation has a number of splendid deep sky objects. Sadly, the Plough is presently too low in the sky, as seen from Europe or the United States, for these to be seen clearly. 2 objects that can be glimpsed higher in the sky are the galaxies Messier 81 and Messier 82, which can be seen in a pair of binoculars. If we join the stars Phakedah and Nubai in the bowl of the Plough with an imaginary line, then continue this an equal distance, you will find the pair quite easily. The galaxies were discovered by the astronomer John Elliott Bode on the 31st of December 1774. Messier 81 shines at magnitude 6.9 and is the top fuzzy object in the field of view of a low-power eyepiece. Its size is 16 by 10 arc minutes and it is situated almost face onto us. M81 contains about 250 million suns. Only one supernova has been detected in Messier 81, named 1993J. It was discovered on the 28th of March 1993 by F. Garcia in Spain. The nova was used as a standard candle to measure the distance of the galaxy, which turns out to be 11.8 million light years. The Cigar Galaxy is the fainter of the 2, and it is situated edge onto us. It is an active irregular galaxy with starburst activity. The starburst action is thought to be triggered by interreaction with the neighbouring galaxy M81 and our own Milky Way. Lying at a distance of about 12 million light years, M82 is a prototype example of a starburst galaxy. A supernova, 2014J, was observed in the galaxy in January 2014. Over the last 9 months, astronomers had been observing supernova 2014J when we noticed a strange type of pulsar. In October, astronomers announced that they had found a pulsating dead star beaming with the energy of about 10 million suns. This is the brightest pulsar ever recorded. The discovery was made with NASA's Nuclear Spectroscopic Telescope Array, or NuSTAR. This surprising find is helping astronomers better understand mysterious sources of blinding X-rays called ultra-luminous X-ray sources, or ULXs. Until now, these were thought to be black holes. The new data from NuSTAR show pulses of bright X-rays coming from the ULX object known as M82X2. Black holes do not pulse, but pulsars do. Pulsars belong to a class of star called neutron stars. Like black holes, neutron stars are the burnt-out cores of exploded stars, but weak in mass by comparison. Pulsars send out beams of radiation ranging from radio waves to ultra-high energy gamma rays. As the star spins, these beams intercept Earth like lighthouse beacons, producing a pulse signal. The NASA spacecraft NuSTAR is helping us to understand exotic binary systems like A-G Pegasi and what happens when the mass of the white dwarf reaches what is known as the Chandrasekhar limit and then turns into a type 1a supernova. I will have more to say about A-G Pegasi later in the programme. While we are looking at the northern sky, let us consider the constellations on view this season. Return to the plough and find the 2 forward stars of the bowl, Marek and Dubai, which are known as the pointers because they lead the way to the pole star, Polaris, in the nearby constellation of Ursa Minor, the Little Bear. It resembles a small saucepan bending down over the plough. The bottom 2 stars, Phairad, magnitude 3.1, and Kokab, 2.2, are known as the guardians of the pole. Because Polaris lies nearly in direct line with the axis of the Earth's rotation above the North Pole, the North Celestial Pole of the sky, Polaris stands almost motionless and all the stars appear to rotate around it. Midway between Ursa Major and Ursa Minor is the winding constellation of Draco the Dragon. The head is marked by the stars Altamin, magnitude 2.4, and Alwade, 3.0, which represents the dragon's eyes. All of the stars of Draco are below the 3rd magnitude, making them difficult to identify. There is one deep sky object in Draco which is of interest to astrophotographers. NGC 6543 is a planetary nebula shining at magnitude 9.0, known as the Cat's Eye Nebula. It is visible in medium-sized telescopes as a blue-green oval. The term planetary is misleading as they have nothing to do with planets. The nebulae are simply a result of a stellar explosion of a dying star. Continue the imaginary line of the pointers an equal distance above Polaris, and you will come to the distinct W-shaped constellation of Cassiopeia, the Queen. During autumn evenings, the pattern lies high overhead and makes an ideal signpost to other nearby constellations. Cassiopeia lies in the star clouds of the Milky Way, so that a pair of binoculars will reveal a number of bright open clusters which are ideal subjects for photography. Close at hand is the constellation of Perseus. You may use the 2 stars Gamma and Delta or Cassora to give it its proper name in the W of Cassiopeia as pointers to locate the bright double cluster NGC 869 and NGC 884, which is a lovely sight in binoculars. This image of the cluster was taken by Oliver Serzenitz. On the opposite side of Cassiopeia from Perseus is Cephus, whose pattern of stars resembles a doll's house. The brightest star, Aldebaran, to give it its proper name, shines at magnitude 2.6 and marks the bottom left corner of the figure, while Zeta Cephei 3.6 marks the other. A little south of the line, midway between the two, is Mu Cephei, or Irakis. It is a variable star of a distinct red colour, nicknamed the Garnet Star by William Herschel. In 1848, it was found to vary in brightness between magnitudes 3.6 and 5.1 in a period of 5.5 years. It can easily be followed with the naked eye, and binoculars will show its red colour. In the lower left corner of the pattern is Delta Cephei, which is one of the most famous variables in the night sky. The star is the prototype after which all other Cepheid-type variables are named. The light fluctuations of these Cepheids continue with clockwork regularity in periods measured in days. Unlike the eclipsing binary variables, such as Algol in the constellation of Perseus, the Cepheid variations are due to periodic pulsations in the star itself. When the number of Cepheids had been discovered, a peculiar relationship was noticed between the length of the period of light variations and the luminosity, or intrinsic brightness. The longer the period, the more luminous the star. This period luminosity law, as it is called, has furnished astronomers with a method of determining stellar distances both in our Milky Way and in nearby galaxies. One of the most famous legends of the stars relates to Perseus and Andromeda and includes Cetus, Pegasus the winged horse, Cassiopeia the queen, and Cephus the king, all of which are on view this season. The name Cetus refers to a sea monster in Greek mythology, although today it is often called the whale. According to the legend, there was once a queen, Cassiopeia, whose daughter Andromeda was exceptionally beautiful. Cassiopeia went so far as to boast that her daughter was lovelier than the sea nymphs or Nereids, children of the powerful god Neptune. Neptune was enraged and in revenge sent a monster to attack the queen's country. The creature ransacked the shores, and before long Cassiopeia and her husband, King Cepheus, were in despair. Cepheus consulted the oracle and was told that the only way to save his country was to chain Andromeda to a rock so that she could be eaten by the monster. It so happened that the hero Perseus had been on an expedition to kill the Gorgon, Medusa, a woman with snakes instead of hair and whose glance would turn any living creature to stone. Perseus had been helped by the gods. He had been mounted upon a pair of winged sandals and given a magic shield which would protect him from the Gorgon's stare. He had been successful in his quest and had cut off Medusa's head. He was flying home on Pegasus, the winged horse, still carrying the head, when he saw Andromeda chained to the rock. At once he swooped down, and as soon as the monster appeared, Perseus turned it to stone by confronting it with the Gorgon's head. He was then rewarded with Andromeda's hand in marriage. Pegasus and Andromeda are now on view high in the southern sky. The W-shaped pattern of stars of Cassiopeia make an ideal signpost, since the two variables Chi and Skida act as pointers. A line passing through them and continue will run straight to the Pegasus. From the square, the line of stars marking the neighbouring constellation Andromeda extends across to Capella in the east, while Merphak, the brightest star in Perseus, fits into the general pattern. The brightest member of the square is often known by its Arabic name, Alpheratz, and in the past it was shown on star charts as 51 Pegasi. For some unknown reason, it has been transferred away from Pegasus and is now officially termed Alpha Andromeda. Its magnitude is 2.1, so the star almost equals Polaris. The other square stars are fainter. Alpha Pegasi or Markab is a magnitude 2.5, Algenib 2.8 and Beta Pegasi or Skeet. Skeet is the most notable star in the constellation. It is a vast cool red giant. Skeet is more than 195 light years away, and like Betelgeuse and Orion, varies in size during its 43.6 day period. Its size varies between 145 times that of our Sun at minimum to over 160 times at maximum. The star's magnitude varies between 2.3 to 2.7 and it is of a type known as a semi-regular variable. Skeet is losing mass at a rate of 9 times that of the Sun each year, which is creating an expanding shell of gas and dust with a radius of about 1,500 million kilometers in space. The only other important star in Pegasus is Enif, which at magnitude 2.3 is well away from the square and is in a relatively isolated position between Alpha Pegasi and Altair in Aquila the Eagle. It is an orange supergiant star lying 960 light years distant. Lying near Enif is A.G. Pegasi, an unusual star that brightened to magnitude 6 around 1870 before dimming to magnitude 9. It is a vampire star composed of a red giant and a white dwarf, estimated to be around 2.5 and 0.6 times the mass of the Sun, respectively. With the white dwarf's outburst taking over 150 years, it has been described as the slowest nova ever recorded. Binary stars like A.G. Pegasi go on to become 1A type supernova. The only deep sky object of interest is M15, looking like a fuzzy magnitude 6.2 star. It is easily found 4 degrees northwest of Epsilon Pegasi with a pair of binoculars. Messier 15 was discovered by Maraldi on the 7th of September 1746. M15 is a fine globular cluster covering an area of 12 arc minutes, and its stars are resolvable in 10 cm telescopes. The globular cluster lies at a distance of 33,600 light years. Linked with Pegasus is Andromeda, the princess of a legend in which Perseus, Cassiopeia, Cephas and Cetus play the other leading roles. Andromeda's 2 stars are arranged in an irregular line running from the square towards Perseus. In order, they are Alpha or Alpheratz, magnitude 2.1, Delta 3.3, Beta 2.0 and Gamma or Almagh 2.1. Almagh is a nice double star visible in small telescopes with a contrast of green and orange. The constellation contains not only the nearest but also the brightest galaxy in the night sky, which is visible to the unaided eye. The Great Andromeda Galaxy has been known since ancient times, and observations of it go back to AD 905. These images of M31 were taken by award-winning astrophotographer Carrie Hancock. Charles Messier first observed the galaxy on the 3rd of August 1764 and included it as number 31 in his famous catalogue. To locate it, first find Beta Andromeda, which is easy enough, then look upwards. You will see 2 fainter stars, Mu of magnitude 3.9 and Nu 4.4. The spiral lies close to Nu, slightly to the right. In 1923, the American astronomer Edwin Hubble found over 70 Cepheid variables in the galaxy. As soon as the Cepheid has been studied and its period measured, its distance can be worked out, and Hubble realised at once that the spiral must be an external system. Modern estimates place it at 2.2 million light years from us, so that we are now seeing it as it used to be before humans appeared on Earth. It has also been found that the spiral is appreciably larger than our own galaxy, the Milky Way. M31 contains objects of all kinds, ranging from giant stars to clusters, gaseous nebulae, novae, occasional supernovae, and it emits radio waves. M31 has two fainter satellite galaxies, M32 and NGC 225, which are visible in moderate-sized telescopes and together make an ideal photo opportunity. Most of the outer galaxies are racing away from us at high speeds, yet astronomers have found that our galaxy, the Andromeda Galaxy, the spiral in the constellation of Triangulum, Messier 33, the two southern clouds of Magellan, and various smaller systems, make up what is known as a local group, whose members are not receding. In this local group, the Andromeda Galaxy is a senior member, while our galaxy takes second place. Triangulum lies between the bright star Hammel in the constellation of Aries, the Ram, and Gamma Andromeda, and contains the three main stars Beta, magnitude 3.1, Alpha, 3.6, Gamma, 4.1, but are arranged in a triangle. The constellation contains the bright galaxy M33, discovered by Charles Messier on the 25th of August 1764. Terry Hancock also took this image of M33, but shows it nicely. The galaxy shines at magnitude 6.7 and is easily visible in binoculars. M33 lies to the upper right of Alpha Trianguli, or Metalla, and covers an area of 55 by 40 arc minutes. Again, it does make an ideal photo opportunity for astrophotographers. Aries is famous as being the first constellation of the zodiac, the point known as the vernal equinox, where the sun's yearly path among the stars crosses the celestial equator. However, due to the slight shifting of the Earth's axis, we call precession, it has moved the vernal equinox out of Aries into the adjacent constellation of Pisces. However, the term first point of Aries is still used. The vernal equinox takes place around the 21st of March each year. Alpha, or Hammel, to give it its proper name, is of magnitude +2 and can be found south of the Andromeda chain. It is rather isolated and there should be no difficulty in recognizing it. During autumn evenings it is high in the sky. There are two more stars of reasonable brightness, Beta Sheraton, magnitude 2.7, and Gamma 4.0. Gamma, or Masrafim, is a fine double star, although it is not a true system. In this case, the two components of magnitude 4.8 and 4.7 just happen to lie in the same line of sight as you, the observer. The brighter of the two is 148 light years away, while the second is 42 light years further still. There are no other deep sky objects of interest in the constellation. The constellation of Pisces the Fishes is also high up, but it is not easy to find because its stars are so faint. Even the brightest of them, Eta, is only of magnitude 3.7. The best way to find it is to use Alpha and Beta Eris as pointers. The main constellation is made up of a long string of stars below Andromeda and the square of Pegasus. If you connect Beta and Gamma Pegasi and continue the line for an equal distance, you will arrive in the middle of Pisces, and it should be possible to identify the group at once. But there is nothing of interest to be seen except the planet Uranus. The planet is at magnitude 5.6 and lies directly below Delta Pisceum. The Pisces chain ends below Alpha Pegasi in the square. When a star comes to the end of its life, it explodes as a supernova, leaving in its wake a planetary nebula. There are two fine examples of these nebulae in the nearby constellation of Aquarius, the Water Bearer. Again, the square of Pegasus gives us a guide. A line from Alpheratz passed through Alpha Pegasi and continued for a greater distance will arrive at the third magnitude star, Alpha Aquarii or Saddleback, one of a quartet arranged in a regular line. Beyond Alpha is Beta of magnitude 2.9. The only other reasonably bright star in the group is Delta, magnitude 3.3, which lies along the imaginary line joining Alpha Pegasi to Fomalhaut. Aquarius spreads over a wide area, touching Capricornus, the goat, on the one side and Cetus on the other. The direction line used to find Fomalhaut, running between Beta and Alpha Pegasi, will cross first the tail of Pisces and then extend into Aquarius. Roughly halfway between Alpha Pegasi and Fomalhaut, slightly to the east of the line, may be seen a small group of stars which looks rather like a cluster. However, it is not a genuine group and is not of any real significance. It is worth looking at with binoculars since several of the stars in the pattern are orange in colour. The Saturn Nebula, NGC 7009, lies a little to the right of New Aquarii. At magnitude 8, this planetary nebula appears as a greenish-yellowish hue in small telescopes. It was discovered by William Herschel on the 7th of September 1782 using a telescope of his own design. Here is a photograph of the Helix Nebula, again taken by Terry Hancock. NGC 7293 has a magnitude of 7.9 and lies southeast of Delta Aquarii. It is again visible in small telescopes and is a classic example of a planetary nebula that formed because of a supernova explosion.
So when stars like our Sun, or slightly more massive than our Sun, die, they lose lots of their outer envelope in a massive stellar wind. And this massive stellar wind enshrouds the star in a dusty molecular-rich cocoon, and then it coasts away from the star. And then as the core of the star is revealed, it photoionizes this outer envelope and illuminates it, making it glow, and it appears to us as a planetary nebula. So the cometary knots in the helix point towards the central star which created them. And this happens in a two-step process. The first step is a shock, and the shock is like pressures in the Earth's crust which creates higher density rock and it creates higher concentrations of gas in the nebula. And the second step is the radiation. The radiation is like rain on the Earth, which trickles down and removes all the loose stuff around, and it reveals the hardened rock underneath. And these hardened rock is essentially these cometary knots that we see in the helix.
Now, I have another variable star for you. Omicron Cetus, or Mira to give it its proper name, which lies in the south at about 10 p.m. Cetus the Whale is another large constellation with few bright stars. However, it is not hard to identify its leader, Beta Cetus, shining at magnitude plus 2.0. The method is to go back to the square of Pegasus and use Alpheratz and Gamma Pegasi as pointers. The lining up is not exact, yet it is quite good enough, since Beta Cetus is isolated. The only possible confusion is with the star Fomalhaut in the constellation of Pisces Australis, the southern fish, which is further west and considerably lower and almost a magnitude brighter. Having located Beta at one end of Cetus, the next step is to find the whale's head at the other end of the constellation. For this, Beta Andromeda and Alpha Eris may be used. The head is marked by 4 stars, making up a 4-sided figure. The brightest star, Alpha or Deneb Kaltos, is orange in colour and of magnitude plus 2.5. When I observed Mira on the 23rd of October. It was of magnitude 8 and it is now fading. Mira has a long history. It was seen by the Dutch astronomer Fabricius in 1596 and recorded as being of the third magnitude. However, a few weeks later it could no longer be found. Mira has a period of about 331 days. At its best it may equal Polaris, and when at its minimum it fades down to the 9th magnitude. Generally, Mira is visible with the naked eye for about 18 weeks of its full period, and sometimes it remains in view for over 20 weeks. The next maximum will occur on the 25th of June 2015. Mira is the prototype of an entire class of stars known as Mira-type variables. Although once like our Sun, Mira is now at the end of its life and has evolved into a cool red giant star that is highly variable in brightness. Contracting and expanding every 331 days, Mira sheds vast amounts of material through its powerful wind of gas and dust. Mira's vampire companion is a burnt-out star called a white dwarf that is surrounded by material captured from Mira's wind. At a distance of about 400 light years, Mira is the closest wind-accreting binary system to the Earth. Ultraviolet studies of Mira by NASA's Galaxy Evolution Explorer satellite, GALEX, have revealed that Mira sheds a trail of material from the outer envelope, leaving a tail 13 light years in length, formed over tens of thousands of years. It is thought that a hot bow wave of compressed plasma is the cause of the tail. The bow wave is the result of the interaction of a stellar wind from Mira A with gas in interstellar space, through which Mira is moving at an extremely high speed of 140 kilometers a second. The tail consists of material stripped from the head of the bow wave, which is also visible in ultraviolet observations. The autumn sky is fascinating at this time of year. There are not only bright examples of spiral galaxies on show, there are exotic objects such as vampire stars. I hope that you are now inspired to go outdoors and see some of these for yourself, especially the great Andromeda Galaxy, the M33 spiral in Triangulum, and the bright globular cluster M15 in Pegasus. That is all we have time for this month. If you are interested in taking photographs of deep sky objects, I recommend Amateur Astrophotography magazine, which is a free monthly publication. Please visit the website at amateurastrophotography.net. Please also visit our own website, Vimeo, where you can watch all the past shows of astronomy and space. And if you like this program, please share it with your friends and members of your local astronomical society. Until we come back next month, good evening.